Bismillah. Assalamu alaikum wa rahmatullah. Ramadan Mubarak Kareem to all of you guys, especially those who are observing Ramadan. Good morning, good evening, good afternoon. It depends on from where you are joining the program. Welcome to Big Bang Data Science Solutions Ramadan program. This is a free program we offer every year in exchange for $150 donation to any church, any organization, non-profit organization, any masjid, any family of need, regardless of the race, regardless of the faith, regardless of the location. Just donate and we will train you. And Alhamdulillah, in the last 3 years, I personally raised over 150,000, all went for donations. Most of you, you are joining, especially from Dubai and other part of the world, you are joining for free. That is totally fine. But if you have money, you can donate. Please go ahead and help someone. And you don't have to send me your receipt, but please help, and we will train you. So today we are going to do in week number 1. We talked about why you should become a data scientist. So it was a lecture that we talked about data explosion. We talked about what is data science, why data science, why do I need to become a data scientist, what's so big about data science, and how to become a data scientist. So we talked about that, and the lecture is accessible either through the Canvas, the platform we are using to host our training materials, and also it's accessible through my YouTube channel. Then we moved into week number 2, where we spent time understanding and exploring the methodologies used in data science, especially the CRISP-DM, which stands for Cross-Industry Standard Processing for Data Mining. This is simply a process or a methodology that I use to monitor and to control and monitor your progress through your analytical project. Then, since we are using Python, we spent one session with Professor Ed Bujak it was an introduction or crash course in Python, simply get you familiar with basic things about Python, since we'll be using Python in this class. And today we are going to move into week number 4, and we are going to be spending time understanding the data, applying data, exploring data analysis. So we are going to read, we are going to explore data number 1. Number 2, we are going to read this data to Python, and we are going to start exploring it, applying some descriptive analytics, some statistical analysis, some data visualization, creating some graphs to help us understand data better. So the more we understand about our data, the better you are off in designing a solution that fixes the problem. So understanding the data is a crucial step in any analytical project. Okay, so we are going to read the data. We are going to learn the spread of your data, the dispersion, the position, the relationship, the shape, etc. And that is week number 4, which is today. So let's jump into before we dive deep into today's session. I see that more than 60 students have not accepted the invite yet. I don't know, 61. So yeah, please, if you don't have access to the Canvas yet, please reach out to me and I will give you access. Or simply check your email. You should be able to access the Canvas by accepting the invite. So I got 61 students out of probably, let me see. So I got 214 students in the class, and 61 have not yet accepted the invite. I am going to resend. So please check your check your email address that you're registered with, and you should be able to get an invite. And why do we need to access this canvas? Simply, if you are interested in accessing the training materials and the recording. So click on modules, then you should be able to see week number orientation. Then you should be able to see the week number 1, the training materials, the recording, the discussion board. Week number 2, training materials, then the recording, the discussion board. Week number 3, the same. And today we are going to do week number 4, and we are going to learn about training material. We are going to have access to training materials, the recording, and the discussion board as well. Okay, so any questions, concerns so far? Any questions, concerns so far, please?
Hi, Mo.
Yes, ma'am.
I don't see this week's training material in the canvas yet.
Yeah, is there a way you can share your screen, please?
Yeah, sure.
Yeah, I'm going to make you a presenter. And if you can change your name, that would be great. Yeah, go ahead and share your screen, please.
Can you see my screen now?
Not yet.
I started sharing.
Go ahead and share again, please. There we go. Now we see it. Okay. Yeah, please log into your canvas.
I'm here.
Okay. Yeah. Now, yeah, week number 4 is not yet open. We'll do that later today.
Okay, that's fine. No problem.
Okay. But you are good. Thank you, ma'am.
Yeah, thank you.
Thank you. Okay, folks. So back to the lecture. So now we are going to talk about understanding the data. And so we are going to go through this presentation, and after that we are going to do a demo, a real demo. And by the way, this is a real business problem for a real industry using a real mask data. Okay, so today we are going to talk about data types. We are going to talk about some measurements, how to measure your data, to make sense of your data. Then we are going to look into some quality problems like missing values, outliers, duplicates, and redundant records, etc. You never know what you are going to face when you are dealing with your data. Okay, so we are being hired as data scientists, and we are working for this our insurance company. So the problem that we are trying to solve is, in spite of having a fraud investigation team that investigates up to 30% of the entire all the claims made, we are still losing too much money due to the fraudulent claims. So this is a problem. This is a problem that this industry or this business is struggling with. They are losing money because of the fraudulent claims, even though they have an investigation team that investigates up to 30% of all claims. So this statement is called a problem statement. It's called a problem statement. And problem statement is not ready to go yet. Is not ready for analysis yet. It's not ready. So we have to transform this problem statement into an analytical statement, into an analytical statement, or into quantifiable statement. So we have to transform it into an analytical statement or quantifiable statement. This statement is vague. There are many directions you can go to, but we don't have a budget, we don't have enough resources, and we don't have a time to spend and trying to try all the directions. We have to determine the optimal directions right on the fly. So we are data scientists. Now we are working for this company, and we need to design a solution that would save the company some money that's been lost because of fraudulent. Any questions, concerns, please? Any questions, concerns about the problem statement, please? There is no stupid questions. No one is going to laugh at you. No one is going to make fun of you. We don't know you. So please ask your questions. Otherwise, there is no way I know that you are struggling, you are, or you have a doubt, or you have a concern. If you don't, share that with us. Any questions?
Hi, about this Mazhar here, right? My question is, this problem statement is still defined at too high level, right? They're not really talking about what type of fraud is happening. It's not really be enough information to decompose it further.
That is true, and it's a problem statement. Then you need to decompose it. You need to break it into pieces, and that is what we call analytical statement. You need to transform it.
Okay.
Okay, you need to transform it. Okay, so now there are a few cases, that we could start.
Sorry, apologies. This is Khalid. Just one question on the previous slide. So the 30%, the way I understand is that they are the fraud investigation team is only doing sampling of 30% of all claims, correct? Okay, thanks.
You could ask why.
Yeah, that's my question.
Yes, I don't have.
Why only 30%? There may be more, right?
No, yeah. Let's say that we have 1,000 claim a day, and I have a team of 2 people. Do you think these 2 would investigate 1,000 claim every day?
Yeah, I mean, you have to do some sampling. You cannot do 100%.
It's totally impossible.
You have to figure out some sampling, and maybe their threshold is 30%. So.
Yeah, that
It's
is
maybe a random selection.
It's random, yes. And this random, the problem with this random, it could be all fraudulent. It could be all legitimate.
Right.
It could be a mix. And they brought you in as an experienced data analytics and data scientist because we want to replace that method. Right now, we have 2 or 3 or 5 or 10 or 20 employees who are investigating randomly 30%. But there is a higher error because it's random, higher error in that 30%. So we want to fire 30 or 40 or 10 or 5 employees that are doing this investigation, and we brought you in. We are going to pay you 150,000, 160, 200,000 because you are going to replace 10 people doing investigation, but we want you to design a solution that do a better job than this team. That is your job. That is why I am ready to invest in you and bring you in to do a better job. Are you ready for that? So,
Brother Mo, so does it matter how the 30% is selected as a data scientist? It doesn't matter, right?
It doesn't really matter for this problem because we are still losing money. So we don't want to do that anymore. That is something that we are doing today. And tomorrow, once you design a solution for us, we are not going to do it anymore.
And who determines that they are still losing the money? It is possible. How do they know that they're losing money if it's?
Yeah, they know.
Because if they don't know, it's.
They know. So they've been. They have 20. Let's say they have 20,000 client. They're supposed to make at least $1 million, but now they make $500. Right? Is that a lose or a gain? That is a lose.
It's a lose, but it could all be legitimate claims.
Yeah, still, yeah. If it's legitimate, then you are going to get something out of the other parties. If it's legitimate, you are going to get some money. But if it's fraudulent, you are going to lose 100%. Legit, you are going to get that 50-50 win-win. But if it's a fraud, it's 100% 100% loss. And this some good questions that you need to ask the business. And data science starts not the first thing or the first thing that you have to be engaged so heavily from the early day or the early stage of this project is asking questions. Data science is all about asking questions. Why 30%? Why, who's doing this 30%? Is this random? How do you measure losing money, gaining money? That's I come up with a bank of questions. That is data science. And that is your job as data scientists. And you guys, you are doing good job so far. Asking questions. And you need to ask who? Ask the business, ask the expert, ask the data expert, the domain expert, the business expert, ask your management, ask the stakeholders. So you always need to ask questions, and data science starts with asking questions. Clear? Guys, clear? Are we on the same page?
Thank
Yes.
you.
Good. Okay. So now, as I said, there are a few cases we could go. I prefer to go with our insurance, unless you want to go with the bank or online charity. I don't have I have data for bank. I don't have data for charity, but I'm going to go with our insurance. So the problem again is, in spite of having a fraud investigation team that investigates randomly, or I don't know how they do that. They investigate up to 30%. Why 30%? Because of the capacity. That is what they can do, unfortunately. If they were to investigate 100%, they don't need you. And even though we have an investigation team, we are still losing money because of the fraudulent. Okay, so as data scientist, there are a few things that you need to determine to help you design a better solution. Then number one, you need to understand what is the as-is state. As-is state. How is the business is being managed, is being operated as at this point of time. Excuse me, guys, before that brought you in. So what is as-is state for this problem? Can anyone tell me? What is our as-is state?
Losing money.
They're losing money. Like
Then what else?
they're losing like whatever the claims they have made 30% of the
Yeah,
claim.
we are losing money. We have an investigation team that investigates up to 30%. That is the as-is state. That is what we have at this point of time.
Yes.
Then you need to determine, the business is going to tell you, we want to be there. We want to be, we have to lose. So last year we lost 1 million in 12 months. Of course, you need to come up with a plan that is reasonable. You cannot say, I want you to design a solution that's guarantees 0% in 1 month. It's totally impossible. So it could be the business will tell you, we want to reduce that 1 million by
Maybe
50%.
minimize the loss.
Not to we are going towards the 0%, but not in 1 month.
Yes, I agree with that.
With
Months,
some
8
But
target.
not in 1 month, yes. The goal is to minimize the loss, but not in 1 month.
Yes, so to be state, that is something that the business is going to tell you. And it has to be quantified.
Sorry, didn't mean to interrupt you, but just a question there.
Yes, sir.
For the state, the targets have to be very quantifiable, right? It can't
We
be
are
that
not
we
talking
want
about
to
target
minimize.
yet. We are not talking about target yet.
No, to be state, like.
Yeah, to be state is what we want to transform to.
Okay.
And
So does it
within
have
to be state, there is going to be a target.
Okay.
Okay, so we have how we are doing business today, and this is how we plan to do the business once we hire you. So you as data scientists, we have to be familiar and be understandable of the two states, as is and to be. And of course, we are going to be helping the business to transform from as is state to be state, but we have to have a measurement. How do you measure that you are successfully transformed from as is state to be state? We have to have a measurement. There are two measurements. There are business measurement and they are your own measurement or your modeling or technical measurement. Business measurement, that would say, Mr. X, okay, I want you. We could tolerate losing 25, reducing the 1 million that we lost last year, and we have forecasted that we are going to lose more. We want to reduce that by 25% the first 3 months, then 50% the next 6 months, then 80% 9 months, then 100% 12 months. So we got a value, got something to rely on, to act upon. And that is the success. The success is once we have the model, once we have the solution implemented into production, we are going to measure how much money that we lost in the first 3 months. So if you are off with $1, then you failed. Yeah, we are not going to be perfect, but we have to try to be as perfect. Have to meet the criterion as much as we can. Okay.
So I have a question.
Yes, sir.
So to identify the success, we need to have a problem also. We need to identify the problem. Like the problem is like we are losing money. That's a very generic term.
Right.
So in terms of data, we need to identify the problem also somewhere before the success.
Right now, you cannot, right now you cannot talk about data. I don't care about data yet. The first thing gotta do, and as you mentioned, is we have to understand the problem first. Data comes next. And trust me, I have asked, in the last 6 years I've been teaching this class, I have asked many managements, how do you start? What do you, let's ask you the same question. So I brought you in today as data scientist, and I'm trying to address your question, brother. I brought you in as data scientist, and I brought you to my office. I sent an email to all departments introducing you, your capabilities, your skills, your education, and this and that. And I simply introduce you, and I introduce your position and what you are doing for the business. Then I asked you, Mr. Azam, Mr. Badi, Mr. Abina, in spite of having a fraud investigation team that we have designed, that they investigate up to 30%, we are still losing money. And the question to all of you, how would you start? What would be your next step? And trust me, most of the answers that I got are wrong. And of course, your answer is going to be differently related to your background. If you are coming from statistics background, you are going to have a statistical answer. If you are coming from data background, database background, of course, you are going to tell me, give me the data, give me this and this and this. If you are coming from the business, you are going to give me your... But the answer to this question, what to start with, is what I mentioned earlier in one of the sessions, is Albert Einstein said, if I was given 1 hour to save the planet, yeah, this is Albert Einstein saying, yeah, if I was given 1 hour, yes, if I was given, can you guys see? It says, if I was given 1 hour to save the planet, I would spend 59 minutes defining the problem. He's not talking about data. I don't care about the data at this point of time. Let me understand what you guys struggling with first. The way you understand it from 360, from all the corners. If I was given 1 hour to save the planet, I would spend 59 minutes understanding the problem, defining the problem, and 1 minute. Only one. The solution isn't easy. If you misunderstood the problem, whatever comes after it won't make sense. It's a waste of time and energy. So yes, forget about the data.
Exactly. Yeah, exactly. That's what my point is. We need to, at some point, we need to identify what the problem is.
Yeah, that's what we are trying to do here. So that's what we're trying to do. So again, always start with raising questions, start with understanding the problem. Forget about the data. I don't care about the data. You could use the data to help you understand the problem, yes. But in most cases, I don't care about the data. Let me spend time with you first, understanding the problem. And to help you understand the problem better, you really need to start with building a team. And we talked about this in previous sessions. We have to have a team. And in that team, we are going to need to have 3 expertise. What are they? We have to have 3 expertise in the team. So this is your team. So number 1, we have to have a business expert or domain expert. Business expert, domain expert, they know the business better than you. You just got hired a moment ago. There is no way you know the business that have been doing business in the last 50 years. No way. Regardless of how good you are in how fast you are in learning, how smart you are, there is no way you are going to get acquainted about the business end to end. So we have to have a business expert and domain expert. Domain expertise is very, very important. Otherwise, you might end up doing some stupid mistakes that would mislead the decision management making.
Brother, what is the difference between a business expert and a domain expert? Are they the same, or is it an interchangeable term?
It could be. I'll give you an example. Business expert is someone who knows the business and knows how we operate. We knows the competitors. You know how many employees we have. We know the department. He knows everything. Okay, let's talk about the our insurance. Our insurance. Okay, the business, he knows how many cars we have. He knows how many clients we have, how many how many the distribution across the country. He knows the pros and cons. He knows everything about the business. The domain expert, he knows the detailed information about the our insurance business. He knows that you have to be 19 to get insured. He knows that if you are driving 500 miles a day, you need to have probably $50 extra. So he knows a lot. It's detailed. The main expert is detailed. Business expert is generic. It could be one person. It could be you, the same person. You are a data scientist, you have business expert, and at the same time you have data expert. You have the domain expert. Right, brother? Clear?
Yep. Thank you.
Okay, you are welcome. And so we have to have a business expert, and of course, we need to have someone who knows the data. Data expert. There is no way you know all the data. And of course, you are not going to use all the data being generated across the industry. You are going to use a specific data. Where is that data? You don't know. I don't know. I just got hired today. So we have to have someone who knows this, who can address our concerns about the data. This person knows where the data is being stored, how the data is being stored, how the data is being created, what are the meanings of every single element of your data, what are the values, what are the ranges of the values. If there is a strange element in there, can you identify it and explain to us? So we have to have someone who can help us understand the data better.
But isn't that the same as a domain expert? Because you said domain expert also knows a lot of data, and the
domain expert that is not a DBA. He could, but yeah. So the data expert is someone who's going to help you get the data you are looking for. So the domain expert, he knows what should be in that data, but he does not know where the data is being stored. He's not a technical guy. He's not. It could be, but he's not a technical guy. He's not the one who update the records, update the databases, delete, update, create. He's not. It's someone else. It's a DBA, right?
Yeah. Okay.
So data expert, someone who knows where the data is being located, how the data is being stored, how the data is being collected. He has answers for your data queries, data questions. Domain expert, data expert, they have answers about your business problems, your business understanding or business queries. And we have you. This is a modeler. You are Mr. You are the boss. Someone who is going to use the data to solve the problem. And of course, we are going to need a developer. We are going to need a developer. Why do we architect? Or someone who is going to take your solution once designed, completed, and implemented for us in the production. I don't have time to. I have time, but I don't have the skills. I am not a developer. I'm a data scientist. So we are going to need a developer, someone who can help us deploy this solution into productions once finalized, once completed. So if you have one missing, so you have a team, you have a data expert, you have I have a developer. What could happen? You could have misunderstood the problem. You could be working on a wrong problem, and of course, what comes after it is a waste of time. So we could, if we don't have a data expert, what would happen? We could be working on the wrong data, or we could be working on the right data, but misunderstanding the problem. The problem is the data is misunderstood. Okay, what would happen if I don't have you? There is no data scientist, then there is no solution. They are still going to be losing money, even though they have a 30%, even they increased that to 50%, no, they are still going to lose money. What is going to happen if we don't have a developer? Then it is going to be hard to deploy the money into production. And trust me, guys, say 80%, I read an article, 70% to 80% of analytical projects, they fail. Fail. Why? Is because either you misunderstood the problem or you are not ready for deployment. So we got the beginning of the project and we get the end. In the beginning, we did not spend 59 minutes out of 1 hour according to Albert Einstein. So we misunderstood either the problem or the data, and we were not ready for the deployment. So we got a beautiful solution, but we need someone to deploy it for us, and we don't have that skills. And if we find someone, a developer, it is going to be so hard to explain in 1 day or 2 days what you guys have been doing for 6 months, and you are expecting him or her to deploy it for you within a matter of seconds. It's going to be so hard to translate what you have done, to him or her, and waiting, and expect them for a good deployment. So we have to have a team. So we have to have a solid team, and this team we have to have a manager. The manager is the one who facilitates our meetings. I am a data scientist. I really don't have time to go look for whom to talk to in terms of business. I don't have time to look for a developer, or I don't have time to keep developer attending our meetings. My job is to design a solution, and I want you as my manager to make this as beautiful as possible. So with this team, then we are going to start asking and understanding the as-is together. We are going to brainstorm what is the as-is, And if you get stuck with something, of course you are going to go to your business expert, dom expert. What's going on here? How does this make sense to you? And get all
Muhammad, a question. So how do you know that you have selected the right business expert or
that's
the
not your
data expert
that
or
is not
developer?
that is not your problem. That is the business problem. You as data scientist, you have to enforce the culture. You gotta tell them this is what I need. I am
But
working on a project. I am working on a project myself, and I've been struggling with this. I don't have a team. I don't have a team. I know the manager is aware of it. They know, but there's nothing they can do because they are not prepared for it. And trust me, I'm struggling understanding the problem, struggling understanding the data. I know what I'm supposed to do, but I don't have the right information. And if you don't have the right information, of course, most likely you are going to make wrong decisions, right? And that is what's going to happen. So the first thing first is make sure that you have a solid team. And if, of course, you don't know who is the domain expert, you don't know who is the data expert, that is something that you need to discuss with your manager. Tell him or her that this is the right way to conduct an analytic. And I would recommend one book. This is the book, and I'm gonna share it with you guys on the slide, on the on the WhatsApp. Can you guys see?
Yes.
Yeah.
Yes.
Let's see, where is the camera? For reason I don't see my. Yeah, this is the book. Okay, it's a really great book, and this is the book that I won this book in one of the conference. It talks about all of this. It talks about it. It's really a must-have book if you want to be a data scientist.
Brother Muhammad, can you share the ISBN number of the book later?
I'll share the book, brother. No worries. Just remind me. Someone reminds me in the WhatsApp. I'll share the book.
Jazakallah.
Yeah, just remind me. I'll share the book. Okay, so now we have a team, and after that, then we are gonna start simply understanding as a state. Now, what is the problem first? I'm sorry. Yeah, what is the problem that the business is struggling with? Then, where the business wants to be, 2 months from now, 3 months, 6 months. Then the measurement, the stress measurement. How would you measure the transition from as is state to be state? And what is the entity? What is the one thing that you are trying to use to transition from as is to be? And in our case, what do you think would be the entity? Or it's called unit of analysis. In other words, if you look into this question, what do you think would be what would we analyze to reduce the amount of dollar loss? What could we analyze? There are many things.
Claims.
We could analyze claims, yes.
Customers.
Customers.
The amount of claims.
Finance.
Or number of claims per driver, maybe. I claim drivers.
It's called payments.
Okay.
Payments. What else?
Locations, towns, like city, town.
That is called customers. Give me the entity. An entity. Give me unit of analysis.
Cars.
Geographical location.
That is customer.
The type of vehicle involved.
That is customer. So claims, customer, payment,
inspectors,
policies. And something else.
We mentioned inspectors.
Something else. Yeah, I mean, who's whom do you think, I mean, who can help us to determine the unit of analysis? Is brainstorming with the team. And we have a domain expert in there, we have a data expert, we have business expert. It could be one person.
Claim manager.
It could be many people in there.
Lost.
So no, I'm talking about unit. I'm not talking about details of unit. I'm talking about the unit is one entity that you think that we could go through analysis to help us reduce the amount of dollar loss.
Claims department.
So yes, we could analyze claims, we could analyze customers, we could analyze payments, policies, etc. Okay, so what would be the unit of analysis? Of course, we are going to use claims. We are going to use claims. We could use clients, we could use payments, we could use policies, you could use anything. If you are a manager managing this team and you have enough resources, you have enough data scientists, you have enough data analysts, you have business expert, I could go all directions. I could assign a team of 3, 4, 5 claim analysis, customer analysis, payment analysis, policies analysis, and something else analysis. I could do that. But since we have, we have a limited time to complete this project and limited budget, then probably we are going to go with the most potential approach. And they believe if we were to analyze claims, that would lead to something beautiful. And within these claims, what are we trying to find out? What are we trying to target within the claims?
Fraudulent claims.
Or it's going to be fraudulent or legitimate.
Legitimate.
It's going to be a 1. It's going to be I think this is a 0. I'm sorry, this is a 1. Yeah, this is a 1. And this is 0. And now, technically, how you are going to do that? Then we are going to do classification or regression or any type of models. So this is your roadmap. This is what you will be doing for all problems that you will be working on, including this problem that we are about to go through. So number 1, understand. Now you have a team. As a team, don't work on a project on yourself. I promise you guys, I lost one project back in 2017 because of the same stupid mistake I did. I was excited to get hired by a friend of mine. He's a very close friend of mine. He gave me a project. I underestimated the amount of time needed to complete the project. I promised to give him a result by the end of the day, but it took me almost 3 weeks simply trying to figure out what's wrong with the data. And guess what? I was fired. I lost it. Okay, so the first thing you gotta do is work as a team. Of course, you might end up working on a project by yourself, but that don't make it as a habit. You get to enforce your culture with the business. So, questions, concerns? Abolor, please mute yourself. Abdullahi, please, brother, mute yourself. Thank you so much. Okay, everybody, please mute yourself. Don't disturb the class, and you have a chance to stop me at any time. I don't have any problem with that. So, any questions, concerns, please? Are we all at the same page?
I'm good.
Good. Okay. So now let's apply this as is to be success entity. Yes, ma'am.
Doctor, I have a question.
Yes, sir.
So what's the success state? What do we do in that state?
The success is how would you measure the transition from A to B. A to B. The business will tell you, okay, so give me a model, give me a solution that would reduce my loss by 25% the first 6 months. That is a success. That is a measurement. Success means measurement. You have to have a measurement from the early beginning. How would you measure your projects once completed? So we have to have a value in there that we are going to act upon to determine if we were successful or if we failed. So the business will have to provide you with that their determination. How would you determine if a model of a solution is being successful or not successful? And they have to give you a reasonable measurement. If they tell you, I want to reduce the loss by 100% in the first 5 days, I would laugh loud, because that is totally impossible. It could be possible, honestly, but I don't think it's reasonable. It's possible, but it's not reasonable. Clear?
Yeah, it's clear. Thank you very much.
Good. Okay, so we are working on this problem. They are losing too much money because of the fraudulent. And now, what is the as-is state? The as-is state is business. They have losing money, even though they have 30% of. They're investigating up to 30%. That is as-is state. To be state, we want to build a model that determines the fraud based on a claim information provided. It could be one to be state, it could be many to be states. But this is simply an example. Success: reduce the amount of lost money by 50% the first 6 months and 100% the second 6 months. So this business wants to get rid of fraudulent loss 100% in 12 months, which is reasonable. Of course, we could design a model and train and retrain until we bring a model to a state where it does detect fraudulent right end of line. How would the claim, knowing if a claim is fraudulent or legitimate, would stop a problem? Okay, so let's assume that you have the solution, and the solution has been tested successfully, So this is your company. This is auto insurance company, and this is a client. This is let's say Afifa. Afifa just called in, said, "Hey, Mr. X, I'm having an incident. Can you help me?" And so this Afifa's incident, it could be legitimate. It could be she could be lying to us. She could be telling the truth. We don't know yet. So either way, we have to do some investigation. And for investigation, you have to have an investigator, send him or her to the scene, take pictures. At least you are gonna spend $100 sending someone from A to B to take pictures and do some measurement, some investigation, right? So we already lost $100 or $1,000.
Why can't we rely on the police report that's mandatory?
Even you rely on the police report, it could be a fraud. You could always, there are always ways to play around the laws, right? I could do it. I could lie, I could deceive the police, I could do so many things to get into what I want. We can do it. Everyone can do that. But how do you stop? So I don't need. So I already spent 500 or even $10. That is a loss. So when Afifas calls in, is there a way you as data scientist can design a solution somewhere in the middle that takes Afifa's information and it tells me it's okay or no? Is there a way we can put a solution in between you and me that when Afifa calls in to report a claim, the model tells me, hey, don't waste your money on this person. She is a liar. At a certain percentage, at 95, 90%, or 95 or 80% accurate. Or this model is going to tell me, okay, go for it. She's telling the truth. So I don't have time, I don't have even a space to waste $10 on Afifa's claim if she is legitimate. And this is only one claim. How about if you have 1,000 claims per day, and all of them they are fraudulent? So if you were to spend $100 for every claim to investigate before you determine not to proceed, you're already wasting money. Is there a way we can determine the go for this and don't go for this? And that is why we're trying to design. And it's possible, we can do it, and we are going to do it. So the moment you call in, the model is going to tell me yes or no, go for it or stop it. We are going to waste zero money if it's fraudulent. So this is one way to reduce the money loss. We are going to use the dollar loss by not, number one, by not investigating a claim, not wasting our money, our time, and a claim that is fraudulent. Number one. Number two, we are not going to distribute funds. We are not going to pay for your car. We are not going to do anything. So we already, we already saved a couple of $1,000s in your case. So we already saved a lot of money. That is how we are going to reduce this money loss because of fraudulent. Questions, concerns?
Yeah, the question that I had, Mohammed, is so when somebody puts in a claim, the car may have gotten into an accident, right? It may have been stolen, might have been broken into, it may have a damage. So that means when it goes to the goes to the repair shop, that means that it has a genuine case. So how would you determine if it's legitimate or if it's fraudulent? How you mean to say the fraud? How are we defining fraudulent? Is that a question that says that there has been no accident and they're still claiming, or there has been an accident but the claim is fraudulent because it may be something not covered by the policy? How would you define that term?
We cannot define, but that is what the algorithm is going to determine. The algorithm is going to go through the data. This is the data, I'm going to share it with you. So this is the data that we are going to use for this problem. Sorry guys, I closed that. So this is all the data we are going to have for this problem. Okay, so we got a data. We don't know which is which. So we got the data, and this is a lot of features that we have in this data. And now we want to find the an algorithm. What is machine learning? Machine learning is simply a mathematical equation, mathematical function that deals with numbers. Is math. Behind the scenes, all math. So these mathematical functions, they are going to take these numbers and they try to tweak them, look around them, and find and investigate them, torture them to find the hidden patterns, the hidden relationship and signals. And those signals, they are going to trigger if yes or no. They are going to trigger if the claim is fraudulent or legitimate. So once we learn the signals from something that happened already in the past, I can definitely apply it to Afifa's claim. Right? Clear? Clear, brother Shuaib?
Yes.
Yes, yeah, kind of makes sense, but not very clear. But I think we are heading in the right direction.
I will explain that. So in this data, we have month, we have age, we have policy bin date, policy state, policy SSL, policy deductible, policy annual premium, umbrella, zip code, insured 6, education level, insured occupation. We got insured relationship, hobbies. We got capital gains, capital loss, incident date. We got incident type. We got collision type. We got authorities contacted, incident severity. We got incident state, incident city. We got incident location, hours, damage. We got the car. We got do we have a witness? Do you have a police report? Yes or no? Total claim and jury claim. We got auto make, auto model, auto year, and we got the target variable. We got the we got some label in there. So let me ask you questions, everybody. If I were to ask you, out of this 39, I believe there's 39, 39 columns. If you were to use only one column to determine if Afifa's claim is fraudulent legitimate, what would be that one column?
Month as customer.
Anyone? You are going to be
Yes,
surprised. Wallahi, you are going to be surprised.
is it a column A? Months as customer.
Yeah, one at a time. Yeah, hold on. Let me.
Brother, can you repeat that question?
Yeah, hold on. I'm going to repeat the question. Just hold on. So these are all. This is all the we call them the columns. So out of these columns, which column, if you were to take only, so Afifa just called in to report a claim. If you were to use only one feature to determine if Afifa's claim is fraudulent or legitimate, which feature do you think you should use?
The zeros and one columns?
No, brother.
Incident type.
Incident type. Someone else?
Hobbies?
Say again?
Educational level?
Occupation and hobbies?
Occupation, no.
Is it collision type?
No, you are going to be surprised.
Total claim.
Hobbies. How about hobbies? Because that plays an important role in claims.
Insured zip?
No. What was it? I mean, Carolina.
Hobbies. Under occupation, you have hobbies. A hobby.
Did you take any of my previous classes?
No, I did not. Is that right?
Yes, ma'am, it's all right.
Yeah, because if I like to, skydiving, that's a high risk in comparison, or if I'm a cyclist in comparison to be watching YouTube all day.
Yeah, for me as a human, I could say policy date, you could say policy number, you could say age. If you are 70, you be careful than someone who is 19, all right? I could say incident type, but the model says the opposite. The model find out that the most important feature to determine if Afifa's claim is fraudulent or legitimate, or if any future claim, that is hobbies. Where is it? Insured hobbies. This animal here. How is it? I have no idea. And guess what? If your hobbies is chess, you are a liar. Afifa is gonna call. I'm gonna ask her, Miss Afifa, how are you? Are you okay? Are you safe? Do you need an ambulance and this and that? Then I'm gonna ask her, what is your hobbies, Afifa? And if she says I'm chess, I'm gonna hang up. I'm not gonna hang up, but I'll tell her, sorry, ma'am, I need more information. That is what the model is telling us, and we are gonna find this later.
So does business identify these kind of a things, or business analyst, or
What do you mean?
who will identify this? Okay, so this is the high risk. So the business analyst will let us know
That
that.
is your job, brother, as data scientist.
Okay.
I hired you. I'm paying you $180. You better give me something valuable before I fire you.
Yeah, mobile, being a data scientist, how do you know if this data stored by hobbies is correct? Because a lot of people could lie about it. If you are a skydiver, you're not gonna say, oh yeah, he skydives, so you're gonna pay $3,000 more in insurance. They lie, and there is no way for them to prove that.
And we don't want to go that direction. But rely what we have in the data. Yeah, you are asking very good questions. What if I like soccer, then I tell you I like basketball, and you are gonna in hobbies. But most people, they wouldn't lie about their hobbies unless you know what they are being used for. Then you won't be able to. You wouldn't lie, right?
Yeah, no, I mean, but unless you are aware of certain, criteria that is going to increase your insurance, then you're saying, no, I don't have any hobbies. I don't practice that anymore. Or in health insurance, for example, you're not going to say, oh, yeah, I have lapses in memory or things like that, because you're not going to qualify for long-term care for sure for that type of insurance.
But they are not going to tell you. They are not going to tell you what they are collecting data for, and deliberately
Yeah.
not going to lie.
That's the company's problem. Right?
But now you know the hobbies. I promise you are gonna lie, right? Now you know it. Now you know it. You are gonna lie. Next time you.
Not many hobbies lately. Just sitting in the computer trying to learn. So that there's no high risk.
Yeah. Next time you buy an insurance, I know you are gonna put something different in there, but you don't know if that thing is not gonna trigger something. But anyway, this is what the model find out to be the best predictor of as
So what steps were taken to be here and this conclusion that this is the problem?
Yeah, please hold on, everybody. Please hold.
So how we reached to this conclusion that this is the column? So what are the steps
You
taken?
gotta be patient.
Okay.
That's something we are going to learn today or tomorrow or next week. Just be patient, okay?
This was a question, right? Even though with such data and model, right, we are determining that the claim is a fraudulent claim, or we are just saying that the confidence level of this claim is very low?
That is something we are going to talk about later, brother. Okay, we are going to discuss that. I'm not going to answer questions that's going to be addressed later. So all these type of questions will be covered. Yes, Muhammad Khan.
Yes, so we cannot only rely on hobbies, right?
That is true. But the hobbies, the question was if you were to pick one. That is the question. Of course, you cannot rely on hobbies only. There are a combination of many factors. But if you were to pick one factor as a human, you could tell me age, you could tell me education, you could tell me, hobbies is the last thing you are going to think about, right?
Right.
That is why, because we don't know what is the underlying mathematical structure of the data. We simply make decisions based on what we see. What we investigate, what we dig deep into. And the models are doing better job in that compared to us as a human. Okay, let's continue, please. So Aziz, sorry guys, I need to do this one more time.
Brother, a quick question.
Sure.
So it's gonna basically come to conclusion based on customers' previous record and the data they collect during the scene. Is this how it works?
Yeah. So the way it works is we have machine learnings, and this machine learning is simply some mathematical functions that we design to mimic the way we make decisions on a daily basis. So we make decisions every day. based on comparing a few things, based on some information you have, based on probability, based on some errors that you made in the past. We make decisions every day based on something. So we are tired of making these decisions. We want a system to make decisions on our behalf. So we are designing these solutions to mimic our behavior. And this decision, these solutions or this modeling or these algorithms or this machine learning, they have to be trained on something that happened in the past. I cannot predict Afifa's claim to be legitimate or fraudulent if I don't have any historical data, if I don't have anything that happened already. So the business gave us 1,000 claim. The business gave us 1,000 claim that happened already in the past. And for these 1,000 claims, we know which one were legitimate and which one were fraudulent. We know this fact. And now we are going to build a model that is going to find the mathematical hidden behavior between this green animal, which is target variable, and the rest of your data. So we are going to need the historical data. And from that historical data, we are going to dig deeply mathematically into it to extract what we call, in English terms, patterns. But mathematically, it's simply we are extract a mathematical function.
So, doctor, I have a question.
Yeah, please hold on, brother. Let's make sure that it's clear.
Makes sense. Thank you.
Good. Okay. Thank you, man. Okay, brother.
So, was it 100% right? Or it can be like...
Yeah, we cannot do 100% right. If you have a model that is 100% right, that is wrong. You are doing something stupid somewhere. And by the way, just to warn you, please remember this. If I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute solving the problem. And I want you to remember another one, very important. All models are wrong, but some of them are useful. This is another beautiful one. All models you are going to build, they are wrong by default. But of course, they are useful in helping us making the better decisions for our business. So I'm not looking for 100%. If you are getting 100%, that means you are either doing something wrong with your data, your model is overfitting. Your model is crazy. Your model did not learn anything about your data. It simply memorized your data. And we want a model to learn, not to memorize. And we are going to talk about this later in the program. Clear, brother?
Okay, it's clear. Yeah, thank you.
Thank you. Okay, so let's continue, please. And so we have, as a state is we define the problem. To be state, this is where we want to be. And the success is we are going to reduce by 50, by 100, by whatever number that has to be documented from the early beginning. And the entity is we are going to concentrate on the claims. I don't care about the clients. I don't care about the payment. I don't care about the policies. All the concentration is going to be claims. Of course, we are going to borrow data from clients, from policies, from many other areas. But the area of research, the area of analysis, it is going to be a claim themselves, nothing else. So this entity is called unit of analysis. And within this unit of analysis, what are you trying to investigate? So the claim, the entity is going to be claims. And within these claims, we are going to investigate if a claim is fraud or legit. If a claim is 1 or 0. That is what we're trying to investigate. So we have to learn first how these claims were fraudulent and legitimate in the past in order to be able to predict if Afifa's claim is fraudulent or legitimate. So we have to learn from historical data and the business gave us 1,000 claims that we have to learn from. And once we learn something, we are going to definitely determine if Afifa's claim is legitimate or fraudulent. That's clear. Everybody, I know a lot of you guys have been, a lot of you guys, I have few students dominating the conversation, so everybody, so please confirm if you are in the same page. Others?
Yes.
Yeah. Thank you, guys.
Yes.
Okay, and how do we measure that? We are going to use accuracy confusion matrix. In other words, we are going to use classification analysis. We are going to use classification analysis. And classification is a type of learning that we are going to cover later in this program once we get into machine learning. Okay, so as data scientists, we are going to use CRISP-DM. And if you attended the previous sessions, or if you went through all the recording, you should be able to understand what is CRISP-DM. It's simply a methodology used in conducting analytical analysis end-to-end. It starts with business understanding. In business understanding, number one, we need to determine our objectives. Then we need to frame. The brother who asked that the question is vague, is general, that is true. He's still he's right, and we need to frame it. And it starts with answering with questions. And then we need to define the measurement. How would you measure the success? That has to be documented from the early stage. Otherwise, it is going to be so hard to convince the management that you've been doing a good job. So you have to convince them by comparing your end result with the proposed result. Then we have to identify target variable. If we know we are going to do some prediction, then we need to identify analytic approach. And you guys remember there are 4 analytic approaches: descriptive analytics, predictive analytics, diagnostic analytics, and prescriptive analytics. Then we have to identify the deployment. Are we deploying this solution later into production? If yes, then you have to have in your team, you have to acquire a developer to be with you. Otherwise, it is going to be hard to explain what you have been doing for the last 6 months. And we have to have a project plan. We have to have start date, end date. We have to know our team, and we have to know the stakeholders. The definition of stakeholder is anyone having an interest in you solving the problem. So we need to build a relationship with them, because they are going to be the ones who's going to evaluate the end result. We have to have a strong relationship with them and acquire guidance, consult with them, and constant basis, every day, every week. So you have to get their opinion as you progress with your project. Don't stay all the way to the end and talk to them. So you could have done a lot of things wrong that could have been fixed if you were to establish that relationship on the early stage. And fixing a problem towards the end is so expensive than fixing it at the early stage. Always try to fix your problems at the beginning as much as possible. If you wait all the way to the end, it is going to be, you have to prepare to hear the music from your management. Questions, concerns? Okay, and you will be working in this phase. You are going to be working with the domain expert and the business expert, because they know better than you. And sometimes you don't have a data, then you are going to propose based on what you understood from framing the problem, based on what you understood from the objectives. You could propose to the business, this is what the data I think we are going to need. And that data proposal is called ABT, Analytical Base Table. You are going to tell the business, I think we are going to need data about demographics. We are going to need the data about insurance. We are going to need data about cars. We are going to need data about reports. We are going to need data about payment. We are going to need data about policies and this and this and that. So you have in mind what you are going to need. And of course, your team is going to help you. The domain expert, the data expert, the business expert, they are going to help you to design this ABT. And you are going to take this ABT and now we are going to transform it into features. Now we are going to work with the data expert. So data expert, he knows where the data has been located. He knows how the data has been stored, how data has been created. He knows the meaning of the data. So we are going to transform the ABT into features. In the ABT, you are telling the business we are going to need demographics. Can you transform demographics into features? Can anyone try? Can anyone try please transform the demographics, ABT demographics to ABT features, to demographics features. What do you think we are going to need in demographics?
Location.
No, demographics. You are going to need age. You are going to need marital status. You are going to need probably income. You are going to need
race.
Race. Yes, those are features. The umbrella is demographics, and the parents is demographics, and the children is age, ethnicity, whatever you call it, age, ethnicity, marital status, education level, income, and many other features. So we are going to use the ABT to transform into features. And now we are going to ask our DBA to collect the data, and we are going to read the data into whatever tools. In our case, we are going to read the data into Python. And once we read the data into Python, then we are going to try to manipulate that data. We are going to explore it. We are going to visualize it. We are going to apply some statistical analysis. Why do you think we need to do all of this? What is the purpose? Why do we
find the fraud?
Say again?
Find the fraudulent claim.
No, brother. Why do you think we are going to need to manipulate or wrangle, explore our data, visualize our data, apply some statistical analysis?
To make a comparison.
To build a model.
No, sir. No.
We need to clean up the data first.
Say again?
Cleaning the data.
No, ma'am.
To understand the data.
Understand the data. Come on, guys.
To
understand the data.
I was going to say to see the pattern in the data.
To understand the data. No models. We don't care about models yet. Let's understand the data. To understand your data, you are going to apply some ADA, some descriptive analytics, some data visualization, some statistical analysis. And at the end, you are going to have a quality book, a quality report. What is the quality report? It's simply a technical report explaining what you have in the data. How many categories you have, how many numeric, what is the size of your data, where the data is coming from, how many duplicates we have, how many, let's say, time series, dates you have, how many IDs you have, how many missing values you have, how many records that don't make sense you have. So it's all about the quality of the data. Right? Are you guys clear?
Yes.
And we are going to take that report. We are going to take that report to prepare your data. So the report that we designed by going through a lot of data investigation, we are going to use it to prepare the data. Then we are going to deal with duplicates. We are going to deal with missing values, outliers. We we are going to convert categorical data, transform numerical data, we are going to normalize, binarize, factorize, standardize, we are going to apply some correlation analysis, we are going to decompose, aggregate, then we are going to extract some features, and finally we are going to have a new version. We started with the raw data, and now we have a better version. Version number 2 or 3 or 4 is where is ready to go. Raw data, it could be wrong data, it could be dirty data, it could be garbage, it could be anything. So we have to go through the whole process to clean it, prepare it, and you cannot clean the data if you don't understand your data. Understanding comes first. Understanding the quality of the data comes first, then fixing that quality based on the need of the business, based on the need of the research. Okay, folks?
Good.
Okay.
Yeah, over here, brother, you say data, there's a cell in there that says data quality audit, cardinality check. What does that mean? That means, and is that based on the model in your machine language algorithm, or is that based on
So, good question. So what is the quality, what is the cardinality? So I'll give you an example. So let's say that you have a data set. Okay, so you have a data set like this. You have one column that is called zip code. Okay, and you have, how many zip codes do we have in US?
I don't know.
I think 35,000. Number of zip codes in USA. I think 32,000. Yeah, 41,000. Okay. So you got a column with 41,000 zip codes. Okay, you got all 41,000. So, and you need this column. Do you think you can use it with 41,000?
It's going to be too much data, right? I don't think
it's called. I mean, those 41 they are called levels. They are called cardinals, and they're also called hierarchies. They have different names. So do you think you can use them? Yeah, we are going to need to use it, but we cannot use it. What do you think you are going to do?
I don't know.
Yes, you know. I know you know.
You can match the zip codes to another, categorize it like by county or by state.
Yes, sir. Yes, sir. So we are going to reduce this cardinality. How? We are going to transform zip code into cities. No, don't jump to state yet. We are going to do cities. And if you have, reasonable number like 50, 20, we are going to live with it. But if you have too many, we are going to go one level up.
What's the counties?
Counties. Then if does not make sense, then we are going to go to
the state level.
If does not make sense, then we are going to go to, this is county, state, we are going to go to regions.
Yeah, regions.
And if does not make sense, then we are going to go to countries. US versus Canada versus Morocco versus Qatar versus UAE versus India. So you got to reduce the dimensional, the levels of your categorical data, and that is what we called cardinality check. You have to reduce. Okay.
Okay. Thank you.
You're welcome. Okay. So now we have a final version, a version that we can use for our prediction. And with this version, we are going to simply do some modeling. Come on. Yeah, we have a new version. We are going to use it for modeling. We are going to split. This is our historical data. We are going to scale our historical data. And the historical data already been prepared, pre-processed. We are going to build the model. We are going to train the model on a part of this historical data. Most likely it's going to be 80%. We are going to predict or test the model on another part, which is 20%. We are going to evaluate, then we are going to pick a model. We are going to build as many models as possible. We are going to build decision tree, for example, random forest, bagging, boosting, ADA boost, gradient boosting, XG boost, support vector machine, logistic regression, naive Bayes, k-nearest neighbor, name them. We are going to build as many models as possible, but at the end of the day, we are going to have only one hero. And that one hero, there are always rooms for optimization, for improvement using the optimization method or parameter tuning. And at the end, we are going to have one hero with the best parameters. And we are going to deploy that model into production. And we are waiting for return of investment. Return of investment is another term of measurement, successive measurement. That's the flow. That is your day-to-day activities as data scientist.
Okay, no, sorry, I got a question here actually.
Sure.
I was thinking about during the break actually. So how we can determine the success measurement before even we got our hands in the data and everything? So
The business
I
is
just
going to
wanna.
tell you. I mean, let's say that I have Big Bang Data Science Solution. This is my company, right? I know it. I know everything about it better than any one of you in this room, right?
Yeah, of course.
So I'm going to hire you as data scientist, and I'm going to tell you, I want you to build a model that generate more students, and they need 50 students in July. That is my success of measurement, 50 students. So you are going to be.
Students for what?
I mean, that is me. That is my goals.
Oh, okay. No, I'm asking like students for what? Like you wanna get like train 50 students by July or something?
I mean, you could correct me. That is, I mean, but that is my measurement. I am going to set a measurement for this problem ahead of time because I know the business better than my data scientist. So the business is going to tell you we want to reduce the fraud by 50% 6 months, by another 50% 12 months. So that is a measurement. It's intangible. It's not something that you can touch. It's intangible. And we are going to beat. Yeah, we are going to beat that. You have to build a model that's going to bring 50 students in July. Otherwise, you fail. I'm going to fire you.
Even if it's not possible. So.
It is. I mean, that is something that you need to figure out. Yeah, probably it's not possible. Probably.
Yeah.
Not possible.
All right.
But
Cool.
still,
Fair enough.
You got the idea.
Yeah. Cool.
Good.
All right.
Okay. So, yes, ma'am.
So in that slide where you have the whole process, we pick the entity as claims. So let's say if I had not picked claimed, I had picked policies. So at what point do we finalize that this is what I'm going to move ahead with? Or you can always go back and change.
It is,
like, at what point do you
going back, good point. Going back and change might be costly. So you got to determine the best approach right in the beginning. Of course, with the help of your team. If you were working on this project by yourself, you could go by you could analyze policies, and policies is not going to get you anywhere, right? That's why we need someone with non-data science expertise. Data science expertise is not going to build a solution. Data science expertise alone is not going to build a solution. We have to have someone to guide us. Someone all the way from the beginning, they caught this type of problems. They are going to tell you, hey, Mr. X, the policies is not going to take you anywhere. There is nothing to analyze in policies. And think about what would you analyze in the policies to stop fraudulent? It could be maybe a payment. It could be so many things. Yes, but is that the best option? You could say yes because you didn't
Not
have.
at this point, but if you, I was just thinking, if you come across a problem you don't know much about, then how do you? Because it seems like once you have
know much about, most likely you are not going to know much about the problems you are going to be struggling with, and that is why you need to build a team first. You are going to bring someone who knows much about, not you.
Okay, thank you.
You have to have someone who knows everything you need on the problem. And if you are working on a project by yourself, you are going to end up losing it like I did in the past. You are wasting your time analyzing a different direction, different things that probably you should not have gone through that direction. So we need a team. And in that team, we are going to need some folks from the business who have been working for the business for many, many years. They know the business. They have dealt with this type of problems manually or using different techniques. Now they want to simply use data science. They have been dealing with this problem for many years. They know the every single bit of it. They simply don't know how to fix it. They know the problem better than you. So bring them to the team and start brainstorming. And based on the information, you build your solution. If you don't have a team, you are going to struggle. Okay?
Yes, thank you.
You're welcome.
Well, before we move on, well, can you explain more about the ROI?
Yes, ma'am.
I'm sorry.
I said I'm going to kill you. I'm just kidding. What is the question?
No problem. So I'm just can you explain more about the ROI?
Return of investment. How much money that you brought, how much value you brought to the business.
Oh, okay.
Okay. In other words, did you make the success that is set by the business? Did you bring my 50 students?
Okay.
Yes or no? Did you meet the requirement, the criterion of being labeling your project as failed or success? That is a return of investment. I invested in you. I paid you 180,000 per annum. Then what is the value? Have you stopped my loss because of fraudulent? That is, have you improved the quality of the business? Have you generated more deals, more leads for the business? That is a return of investment. I am going to invest, but I need to get something back.
Mm-hmm.
That is a return of investment.
Gotcha. Thank you.
Mo, so when we say define a success, we say, let's for example say you bring in 50 students, right? But by the end of the project, instead of 50, you have 48 or 49. Would you still be considered a success, or would that be a failure?
It certainly depends on the business. The business, they have a tolerance. I will tell you, go see my house, minus 10,000 plus 10,000. I have a tolerance is minus 10 plus 10. I'm going to tell you, bring me 50 students plus minus 5. Means you could bring me 55, you could give me 45, right? But anything below, I don't think, I'm going to be happy.
Okay.
So, of course, when I give you a number, we most likely we don't mean the number. There is a plus and minus, but the plus and minus is within a tolerance, within a limit that is acceptable. If my house would cost 600,000, if you were to sell it for 499, I'm going to be happy. 490, I'm going to be. 590, I'm going to be happy. 610, I'm going to be happy. But if you were to sell it for 580, I am not going to be happy, right? I'm asking for 600,000, but of course there is a tolerance, plus minus 10,000. I'm going to be happy with it. That's likewise with this defined measurement. Some businesses, they are very strict. If you are working in a pharmaceutical problem, they are very strict. You want to design something that is 100% accurate. There is no tolerance, because that single tiny tolerance would kill someone, would cause a life of someone. So it depends also on the sensitivity of the project you are working on. Some of them, they are very sensitive. Some of them, they really don't care. Okay, brother?
Great.
Clear?
Thank you.
You're welcome. Okay, so this is Chris DM. I'm going to skip analytics, data engineer. I'm going to skip data understanding. Now we are going to get to the topic. In data understanding, I'm not going to talk about this. I'm going to simply talk about a few things. So in data understanding, there are 4 types of data: structured data, where we have rows and columns; semi-structured data; quasi-structured data; and unstructured data. It does require some effort to transform it. I would say most of the machine learning algorithms and modeling, they are designed around structured data. Most. Unfortunately, 90% of your data is unstructured. 90% of the data circulating or being generated worldwide today is unstructured data. And most of the models, they are around structured data. So you have to transform this unstructured data into structured data. Okay, in terms of data, there are a few things that you need to know. You need to know if your data is categorical, very important, and if your data is numerical. Why do you need to know that? Because especially categorical data, you need to know the type of categorical data, because most of the algorithms, they are designed, they work better with numerical data. And if you have categorical data, you have 2 options. Option number 1 is to delete, don't use them. But they could have some valuable information, valuable influence that you could use for prediction. Option number 2, you need to keep your categorical data, but you have to transform it into numerical data. I'll give you an example. And transforming is critical, very critical. I'll give you an example. Let's assume that you have a column that called gender. Okay, you have a column that is called gender. And in the gender, we got male, female, etc. Got male, female, male, female, etc. You got 6 million records. So this data here is categorical. It's category, it's not numerical. And we want to transform it into numerical. Can anyone transform this into numerical?
0 and 1.
0 and 1. Good.
That's binary.
0 and
1. Please
hold on, brother. Please hold on.
Mm-hmm.
So the brother who said 0 and 1, okay, what do we need to give him?
We can define anything. We can define it as 1.
Okay.
Yeah, the other one should be 0.
Yeah.
Sister who just spoke, are you happy with that?
I think so.
Please hold on. I'm talking to the sister. Are you happy with us giving you a 0 and giving ourselves a 1?
It doesn't matter, right?
No, it matters. Are you happy? Yes or no? Are you inferior to us? Yes or no?
So what's the question? Come again? I'm happy. I'm not blaming.
No, you are not happy.
No, I think it would be biased if you put
There
M
is
as
no
1,
bias,
F
yes.
as 0. It could be the other way around also.
It is biased, but if I do like if I put like 1 for F, that is also biased, right?
No,
How
here
can
we
we
go.
do that?
What's wrong with this process? Why we cannot transform this data into 0 and 1 like this? This method is called mapping. We are mapping male M to 1 and F to 0. Ethically, it's wrong because models, remember that models, they are all mathematical equations. Means 5 bucks is better than 4 bucks. 10 is better than 5. 100 is better than 20. A million is better than 100,000. 1 is better than 0. Are you telling me, what you are telling the model, you are telling me that all males, they are better than females. And the model is going to treat males different than females inferior than males. Are you happy with that?
No, not first.
Imagine that, and this happened in the airports here in US. They have what do you call it? Those in the bathrooms, they have the faucets. What do you call them? It's where it's a systematic faucets where you simply
Put your hand.
yeah, you
Just put your hand.
what do you call that?
The hand activated faucets.
Yeah, yes. And guess what? This hand activated faucets, they threw water on the white skin, not the black skin. Imagine you go to bathroom, you are very rushed, you are in a critical sorry. It's not water for you. Why? Because you are female. Are you going to be happy?
No. No.
So why this happened? Because we feed a biased data to our model. So mapping is not going to happen. It's not going to work. Why this is not the right transformation? What are we actually doing here? What is the type of categorical data that we have? Is it ordinal or binary or nominal?
It's binary.
Binary.
Binary is 0
No,
and
binary is 0 and 1. Yeah, that's not binary.
what is nominal?
So how would you define ordinal and nominal? That would be the question.
Categorical.
Anything that has any order sense or on order activities, like for example, it has orders. Does this have orders?
No. That's
So
a
it's
nominal.
And what we are doing, we are transforming nominal
Into a binary.
into and this one does it have an order?
No.
No.
Yes, it does. Which one comes first? Which one is higher?
One.
One is better. So we are transforming. We are using a wrong transformation method, and that's what's causing the problem.
Okay.
We are converting nominal into ordinal, and that's what's causing the problem. So we have to use different method. And number one, we need to know the type of categorical data that we have, and based on that, we are going to determine the conversion method. Otherwise, you are going to run into the airport incident. No water for you. Who cares? So yes, we got.
So, Brother Mo, question. So, in this example, you selected male and female, but with the gender bias, I think the US has come up with other categories that you may not respond, and you don't. In that case, you don't have a M or an F there. You simply ignore it. It's optional. Or you could probably there could be some other birth. You don't want to follow your birth gender. There could be so many things. In that case, how would you handle this column?
Regardless, the point I was trying to make, if you're number one, you need to find the type of category that you have. Is it not ordinal? Then you have to use the ordinal transformation. If it's nominal, you have to use the nominal transformation method. Don't switch. Don't use ordinal transformation method for nominal or nominal for ordinal, because you are going to get into bias, regardless of other gender. I really don't care. But
Okay. And who decides? Who decides? Is it the data scientist who decides whether it's ordinal, binary, or nominal, or is it the
that is
data?
your job. That is your job to understand your.
Okay.
Mo,
It's
I
the
want
data
to.
tells you.
Yeah, everybody, please hold on. Yeah, let's make sure that brother is clear before I proceed. Brother asked a question. Who decide? That is what we are doing here. We are trying to learn, understand our data. We, who are we? Me as data scientist and my team. We have, but the responsibility is yours. You are the data scientist. You need to spend time understand what you have in your data. We have here, for example, this is a categorical data. Is it nominal, or is it nominal or ordinal? And based on that, you determine the optimal transformation method. Yeah, please hold on, sister. Make sure that brother Shuaib is clear. Brother,
Okay, so in this case, if you're looking at the state, if I were a data scientist, I would put this in. Doesn't seem to have any order to it, and we can't make it binary, or so it's probably nominal, right?
It's nominal, and based on that, we have to use nominal techniques.
Okay.
Which we are going to learn later. Probably next week we are going to learn data preparation techniques.
Okay.
Good, brother?
Yep, thank you.
Good, you are welcome. Okay, sisters?
So, Mo, just to rephrase what you're saying, so I have two things. I have categorical and I have numerical. The algorithms of machine learning models work with numerical processes better than categorical. The categorical, I have ordinal, binary, and nominal. So when you're talking about converting this and converting this nominal or ordinal after analyzing the data into a binary, so I can transfer it into the numerical.
Let me. You got the first part correct.
Okay, so because I see the binary in the categorical, but from my perspective, it belongs more to numerical because that's how machine learning read things.
Yeah, I mean, actually, the binary is categorical, even though it's a 0 and 1, but the type is categorical. So when you have categorical data, either it's ordinal or binary or nominal, some machine learners, they can handle your data as is, like decision tree or any tree based models like decision tree, random forest, all bagging flavors or boosting flavors. They can handle your data, either it is categorical or numerical. Some algorithms, they really don't work with ordinal, binary, nominal data. You have to transform them into numerical data. And to do that, you need to find what type of categorical data that you have. And based on that knowledge or that information, you can determine the right transformation method.
Okay, I understand that part. So from this example, we have the gender M and F, and I'm converting that M and F into a binary number 1 and number 0. So again, it's still in my categorical data. How the numerical algorithm is going to be applied into that if I'm still remaining into the categorical aspect that is
number one, this is wrong.
Oh, okay.
Okay, I asked you, how do you do that? You told me 0101. That is wrong. Okay, so you have to do another method, which we are going to cover later.
Okay, I understand. So I missed the part that I was mistaken and analyzing this whole slide has this. Okay, got it now. Thank you so much.
Totally wrong. Ethically, it's wrong, and statistically, it's wrong also. You cannot differentiate. You cannot use a data that is biased towards male and female. If I give you 0, I am telling the model I'm better than you. If I give myself a 0, I'm a male, and give myself a 0 and give you 1, you are telling the model you are better than me. And I want a model who treats me and treats you with some equality, with the same equal treatment. That is the model that we are trying to build. Not a model that is going to be biased toward a gender. Okay?
Okay. Wow. So every time I assign a 1 to something and give it more credit than not in this field.
No, sometimes this 101 works. For example, let me give you another example where it works. Let's assume that we have another column that is education level. We got education level. Okay?
Like a student form or
Education level. And in the education, we have master's, we have PhD, we got associate, we got bachelor's, we got high school, we got master's, we got high school, we got bachelor, etc. Can you transform this into numeric?
Yeah, because you have a PhD, so I'm assuming you'll be the top of the chain, sort of.
It's going to be 5. It's going to be 4.
Okay.
So it will be ordinal.
This is ordinal. There is ordinal means there is somehow a type of ordinal and order.
A hierarchy, sort of.
Not hierarchy, sequence. There is a sequence in it.
Sequence, okay.
So when you change it, I mean, which one is better for this education level? Which one is better? Is high?
It's a PhD.
And which one is higher here?
The PhD, 5, number 5. Yeah.
Is 5 is higher, PhD is higher. So we are not actually doing we are not biasing.
Yeah. Right. Okay.
But
thank you so much for the clarification. It seems like common sense, but you really need to see it.
Right.
Thank you.
Yeah, for this one, if you are giving me 1, you are telling me you are better than you. If I give you 1, you are telling it you are better than me. And I don't accept that. You are not better than me, I'm not better than you. We are equal. Okay? For this one, no, PhD is better than a master. You have to go 3 more years or 4 more years after the master. So it's higher.
Yeah, there is some merit to it. Some more work, more expertise, more everything. Yes.
Yes, it is. It's better. Technically, it's better. In theory, it's better. But it could be a master's more experience than PhD. But in theory, PhD is better than master. Master is better than bachelor. Bachelor is better than associate, than high school, than elementary school, than whatever school you are attending. So the bottom line is you need to understand your data. Is it categorical? Yes. What type of categorical? Is it nominal or ordinal? Okay, I'm gonna say a few things. When you are designing your data, few things that you need to worry about, you need to consider. I'm gonna skip all of this. So you need to really pay attention to timing or longevity. This is very important. Longevity is very important. Let's assume that you work for a bank and your job as data scientist is to deny or approve application for a student loan. And today I need a loan. I come to you, then I meet you at your office, and I provide all the information you need from me. Okay, I provided you with my income statement in 2007, 2008, all the way to 2022. Okay, and 2007 I was making 10,000 per annum. 2008 I was making 100,000 per annum. 2015 I was making 50,000 per annum. 2019 I was making 220 per annum. 2021 I was making 70,000 per annum. So which one that you are going to consider to approve or deny my student loan?
The current one.
How long you need to go back? How much you need to go back? So the timing is when you are designing, when you are transforming your analytical base table, ABT, into features, you need to consider timing and you need to consider longevity. You really need, and of course you might not be able to do it by yourself. This here comes the value of having a team, a solid team. Someone from with the expertise will tell you, we are going to go back maybe 5 years. We don't want to go for more mid one is historical for the last 20 years. Won't make sense. Let's do it for 5 years. And they have their own reason. They have their own logic. Another things that you need to consider, imagine that you've been working for a bank and your job is to deny or approve your approved loans, and you have a small data set. You got a small data set. Okay. In that data set we have, this is Mo, client called Mo. We have my age, my faith, my ethnicity, my race, my age, and of course they have my income. Let's say I'm making 70,000 per annum. Age, let's say I'm 40. I'm Muslim. I'm Moroccan. Race, African. Age, something. And they have another students. Let's speak of students from Badu. 45. She is Christian and African, race is Hispanic, and she's making 120. Okay, and now we got two applications and you are the data scientist making a decision. Okay, question to you all. Do you think you can use all these features to yeah, everybody, please mute yourself, please. Question to you all, and we have a model that makes the decision. Do you think this is the right data? Yes or no, and why? To make a model decision.
No, it's insufficient and it's.
We don't know, like, how can we say this is the right data or wrong? We don't know.
No, it is not.
We don't know the question.
Anyone else?
Because we're using text to come up with a number which is like 70 or 120. So
let's make your life easier. Let's make your life easier. Imagine this model denied my application. It denied application for both of us. By law in US, someone must mute him or herself, otherwise I'm going to kick you out. Sayyid Mahmoud, please mute yourself, otherwise I'm going to kick you out. Thank you, sir. My apologies. I don't try to be mean. Okay, so by law in US, you have to give me a reason why you denied my application. Imagine that I got a letter in the morning that tells me your application has been denied because you are Muslim, or because you are a Christian, or a Jew, or because you are Hispanic, or because you are 50 years old, or because you are a female. What's wrong with this?
Biasness.
Say again?
Unethical.
Bias.
It's unethical. It's analytical.
It's unethical and biased.
Yes. So this data could be the right data, but you cannot use them to make a decisions on a human. When you are dealing with human cases, with actual human cases, then you need to be careful about what you are using into making decisions. And in other words, you have to consider the legal right, the legal part, legal issues of your data. How do you know that? Your domain expert is going to help you. So there's a lot of rules and regularization that is going to go after you. I would be more than happy to apply for a student loan and get in the morning a letter that it's been denied because of my age. Do you know what I'm going to do?
Sue them.
Yes, I'm going to sue you. I'm going to definitely sue you.
Mo, can we create a model that is vice versa, that instead of, like, of course, using this data that it might be discriminatory, can we get like one of the Ivy League's data and see if they have been biased in approving
Yeah,
students?
Yes, you could do it. You are a data scientist. You have to keep trying.
It's not gonna be in the best interest though. But I don't think they're gonna get hired for that.
But just be careful. If you are making decisions in a human, be careful of the legal issues. That is the
Is
problem.
it because of the HIPAA rules and all?
Got to be careful about there are a lot of organizations that are going to come after you.
Yeah, that is what is that HIPAA, PHI, something like that.
Yeah, I don't know them, but yes, they have.
Mo, a quick question. So you are a data analyst, or we are a data analyst. We are not the decision makers. Decision makers, the business who has given you the problem statement. You just do the analysis, give them the trends, and they take the decisions. So why are we part of this legal debate? Shouldn't be only the business who's liable for that? Sorry if my question is out of context.
No. You're asking the right question, but you are a data scientist. You are going to give the business a solution or an information to make a decision. So you are coming up with the decisions, with the solutions based on the data that you have. And if your data has a problems, the business does not know. You are the expert. I totally trust you. You are my data scientist. My life is in your hand. So you as data scientist, when you have a data, then you need to consider all these problems before you give me something stupid. Right?
Yeah, thank you.
It's your job. The business is going to provide you your data, the data you are requested. But in that data that you have requested, there are some elements that you cannot use. I am not an expert. I am a business owner. You are my data scientist. You have to tell me. You have to know that. If someone someone sue me, I'm gonna.
So, sir, one more question. Are there any best practices or guidelines how to treat certain kind of data, or should we be using some industry best practices?
Honestly, it depends on the sensitivity of the project. If you are making a decision on humans, on persons, then be careful. If you are making decisions on cars and houses, who cares? Okay, that's a few things to start with. If your project is very sensitive, then you have to be very careful. You have to.
Is there something more that is called like sensitivity analysis, and there's like some parameters will be provided, I guess, from the subject matter experts or whoever.
Yeah, I never did that, brother, but it could be.
Yeah. Okay.
Okay, folks, a lot to talk about. Unfortunately, let's stop here. And we're almost 2 hours. So now we are going to jump straight to Python. So let's do a demo very quick. You guys asked a lot of questions, great questions, which is what I'm looking for, healthy questions. But now let's do a demo very quick. and hopefully we are going to have enough time to go through this. Data science, project goes, Python, understanding the data, loading the data, insurance. Okay. So you should have at least a few, knowledge or few experience with little experience with Python. Otherwise, this is going to be hard. Okay, the first thing we gotta do is we are gonna import some packages. Yeah, we are gonna import NumPy for numerical Python. We are gonna import Matplotlib for data visualization, and we are gonna import pandas for data manipulation and analysis. Okay, and these libraries they come with Jupyter Notebook. Then we are gonna create a variable called our insurance, and we are gonna read into it our data. So this is our data, month as a customer, age, policy number, policy print date. Yeah, we could do columns. We are going to do what is the name? We are going to look into the columns. These are all the columns we have. Yeah, we got 39 columns, month as a customer, age, policy number. And when I asked you one, if you were to pick one feature or one indicator, which one would be? Of course, few of you would think about the hobbies, and I was wrong when I first looked into this data. I never thought the hobbies is going to be the baby, is going to be the hero. Never thought that, and it's hard to tell. But this hobbies, it is going to be the best predictor. This is not my word. These are the word of the models. Okay, and now we are gonna simply, most of the time it's always good to have all these names in lowercase. There is no space, no special character. So we got to, fix them. And there is one library. It's called Generator for Python. There is one library, it's very good. It's called Generator for Python. Insert Generator, okay. Conda. And I'm looking for the codes. Import Generator function. Here we go. So we are going to install, keep install. Pip install the generator. Yeah, it's called Pi. It's called Pi Generator. Okay, then we are going to import it, and we are going to do our insurance. So what does Generator does? The library, it is going to go through all your columns, and it's going to clean them. We are going to use a function called clean names, and it could also remove empty names. Let's run this. It should work, but you could do it also manually. We are going to do, okay, go ahead, replace any space with underscore and transform everything to lowercase. I think it works. Yeah, it works. It's still working. If it goes through an error, here we go. It works. It's done. That's it. Like for example, if I have in this data, at least I do age. I do age, capital H, and I do here policy number space number, and I do exclamation mark. Okay, I'm going to save this data. Save. And I'm going to read this data. Let me find the location first. Properties. Okay, I'm going to read this data, and you are going to see something very important. Okay, there we go. So we got age, capital A-A-G-E, and policy number, we got exclamation mark. Okay, so we got age, we got policy. So this is nothing wrong with this, but it's always good to have in your column names, always good to have all lowercase, and there is no space and no special character. No space, no special character. So this generator, we install, we import, and we use one function. It's called clean names. And now we are going to apply it, and we are going to print columns one more time. Let's see if it's going to work. You see age now. Okay, first we got capital A-A-G-E, and the second we got policy, and we got an exclamation. It simply removed all the space. This is a really beautiful package that you could use at the early beginning to make sure that the column names are really good to go, no problems with them before you proceed. Any question, concern, please?
In order to install that, I am not very familiar with Python, which is something that I had to get caught on that. But you're in order to install this PyGyre, you have that exclamation and PIP. What is that exactly? And do I use that all the time trying to import libraries?
Yes, I mean pip install is a syntax you are going to use to install all the libraries. If you were to use this in the terminal, you don't have to use the pip. Yeah, you don't have to use the exclamation mark.
Oh, I see.
Simply, and this is going to tell you it's already been installed. Okay, so that is a syntax that you need to install any library. Okay, now we are going to do shape. How many features that we have? A shape is a method that is going to tell you how many features that we have. And I believe I lost you guys. Sorry guys, I lost you.
Well, can you hear us now?
Sorry. Okay, so shape is a method. It's going to tell you how many features that we have. Info is another method. It's going to tell you, it's going to provide a lot of information about your data, the type, the number of missing values. So you got 1,000, all the way to the end. So we don't have any missing values. We got some object means categories. We got some categories. And so since we have categories, we know that we need to transform them. And to transform them, we need to find out if they were ordinal or nominal. Okay, and we got another function is called describe. Describe is going to provide so many, a lot of information in terms of the statistical information. Is going to provide the minimum number, the mean, the median, and the max. And the describe only works for numerical data. As you see, it does work for categorical data also, but by default, it is going to provide you the statistical analysis of the numerical data. So let's take a look. Your job as data scientist is to go through these numbers and make sense. Month as a customer. What's wrong with this? What's wrong with this month as a customer? Can anyone tell me?
It's giving me kind of dates instead of days instead of
No, ma'am.
months.
I'm not looking into that. I'm looking into the quality. What do you think about this month as a customer's quality?
The decimals, perhaps.
No.
The 0 months.
Where is the 0 ones?
The min is 0.
Look into it one more time.
Yeah, the minimum shows 0.
The minimum shows 0. What's wrong with that?
That means that that's not a customer at all, right?
Say again? No, it's a customer.
That's not 0 month could mean a couple of days.
Maybe they just
There we go. So what do you think we need to fix? We have to fix this, right? How can we fix it?
Change it to days.
Yes, sir.
Or days. Days as customer.
As a customer. Very good. Because
so why not even change it to hours or minutes?
I mean, it depends, I believe that most of the auto insurance they work by day.
Yeah.
So if you cancel, if you pay a month and you cancel in the 10 days, they're gonna charge you only for 10 days, right?
Right.
So they
Correct.
go by days. So
Correct.
So we go with the business. The business go by days. So this is a wrong measurement. So we need to change this to by day. Otherwise, we are gonna have a lot of zeros. So you've been a client with us for 27 days, and it's still gonna show 0 because you have not completed a month yet, and that is wrong. Age, we got a minimum is 19 and maximum is 64. Do you think that makes sense?
Yes.
Yes.
What if you have in age you have 7? Is this a good? I mean, is this a valid number?
No, it's not a valid.
No, it's
a bad data.
Nothing wrong with 7. Nothing wrong with 7. But in terms of
But being a customer, like it should be an adult, not a child or something like that.
no, it's number 6. Nothing wrong with 7 or 0 or 5 or a million. Nothing wrong with that. But in terms of the main expertise, it does not make sense. There is no, I mean, to get insured car insurance, you have to meet a certain age. So you wouldn't know it, but your domain expert has to tell you that if there is 7, for example, they have to tell you this is not, there is something wrong. It might be a typo, might be something in there that we didn't understand.
So you're confirming the data with the criteria of the business.
Yes, ma'am, and confirm that you have to go through every elements of your data to make sure that statistically they are sound. They do make sense statistically.
And we look for the business rules.
Yeah, business. I mean, there are many ways to do it, but the best way is to, I mean, is to engage your team. Best
No, in the age column, what does 9.1 represent? Standard.
standard deviation is the difference between when we calculate. We have 1,000. We have 1,000 clients, and we calculate difference between the 9.14 is difference between one client and the other is the standard difference between all of them. Okay, the maximum is 64. 25 is called the first quantile. This is the first quantile. This is the second. This is the third. And these three, 1, 2, 3, and 4, and I believe the mean, they are called the 5-number summary. 5-number summary. And the person behind this 5-number summary, his name is John Tukey. He is a statistician, and is the father behind. He has a book. It's 1970. It's called the Exploratory Data Analysis. Just Google 5-number summary. His name is going to show up. The most extreme value of data set, maximum blah, blah, blah. The quartiles, second, third. It's all about your data, and the person behind it is John Tukey. This is the person. So the describe method will provide the statistical summary of your numerical data. If you don't like the format, you are going to do .t, capital T, and it's going to flip the format. Watch this. So now we got, let's compare. So this is, this is one method. Yeah. And now if I do .t, it's going to swap them. And whatever method you use, I mean, it's the same information, but in different format.
Actually better like that.
Yes.
I mean, so
as a column to rows.
We got here measurement in the columns, and we got the columns as in the rows, and in this one we got the opposite. So which
yes,
one?
the transposition.
Yeah, it's
called
transposition. It stands for transpose. You could do .t, and also you could do the transpose. Okay, so the describe only provides the 5-number summary. It's only by default it is going to provide the statistical analysis of your numerical data. What happened with the categorical data? In categorical data, we have to include them. We are going to do include object, or simply O. Describe, okay, our insurance. This is the variable where we have our data, and we are going to use describe and include object. Include objects, and for numerical data, you are going to get the the quantiles, the minimum, the maximum. This is 5-number. For categorical data, you are going to get the frequency and the mode. So for numerical, this is numerical data. You are going to get the 5-number summary, the minimum, the maximum, the 3 quartiles. Of course, you are going to get the count, the mean, standard deviation, which we don't care. And for categorical data, you are going to get the frequency and the mode. And now we are starting learning about our data. What did we learn about our data? We know that we have 1,000 features so far. 1,000 claims. We got 39 features. Then we know that we have some objects, and we have no missing values. And now we have the mean, median, mode. Sorry for all the for the numerical data. We got some information about numerical data. Okay, and we are going to go through this to make sure that that makes sense. We need to look into the minimum, the maximum, minimum, maximum. Make sure it doesn't make sense to you statistically. Otherwise, you need to raise the flag. And for categorical data, we have the unique means the mode and the frequency. Now, policy bin date, we got 951 different dates, and we got 3 uniques. Insured 6, we got 1,000, and we got 2, and we got female. What can you tell about this? Can you tell me something about this? We got more accidents from female side. Why? I don't know. Maybe they are talking in the phone while they are driving, but I don't know. It could be sample data. But we have more accidents from for the sample, more accidents from the female compared to male. But we cannot use this information to make a decision. I cannot charge female because we have more accidents. I cannot charge them $50 extra. I cannot do that. Okay.
Excuse me. What does JD means here?
That is a level of education.
Oh, okay.
Education. You have associate, college, high school, I think jurisdictional something, I don't know. Master's.
Yeah, it's a law degree.
Yeah, I think it's law, yes.
So, yeah, doctor of jazz or something, right? Okay.
Yeah, this I mean, we got a lot of law degree accidents. Law degree.
Yeah, that's what I'm saying. Okay.
Yeah, can we change the policy? I don't know. I don't think. I think we should. Because this is not a bias. If we find out high school are more, if we find that female are doing more accidents than male, we cannot make a decision. We cannot use the gender to enforce a policy. But education level, I think we can. If we have more accidents from JD, of course we are gonna probably charge them extra $100 per premium.
They will sue you.
No, they're not. I mean, it's not. I mean, they will sue me.
The attorney will sue you.
No, I don't think they're going to sue me. Because there is no law for the education level. There are laws for the gender. There are laws for ethnicity, race, and faith, not education level. I don't think you should be able to sue me.
No, I'm just joking.
It could. I mean, in some states you could, but I don't think. But anyway, I hope you get the point that you need to be very careful when you are making decisions as a human. Okay, folks, let's stop here. It's 7 more minutes. Let's stop here. Let's take a look into the target variable. So we went through this 1,000 claims, and to determine if they were legitimate or fraudulent. We find out that 75% out of 1,753 claims they were legitimate, and 247 they were fraudulent. And we visualize it. This is what we are going to see. This is legitimate. This is fraud. Okay, folks, that's it for today. I'll see you guys next Saturday. And by the way, next week We are going to do two sessions. We are going to do a session two sessions every week. We are going to do a session on Saturday and session on Sunday. Hopefully, I want to be able to complete the program by the end of Ramadan or before the end.
Just from a planning perspective, we are doing both days. How long each day, so that we can plan
Is how many questions do you have?
At least 2 hours.
I was planning to do 1 hour, 1 hour and a half, and 2 hours. But if you have questions, of course, it's going to be longer.
Got it. Okay, thank you.
So, Brother Mo,
let me stop.
So you say that we'll meet
Shall I please hold on? Let me stop. This graph here represents the legitimate claims.
Okay.
And the one is this is a positive. They are fraudulent. This one is negative. They are not fraudulent.
Got it. Thank you.
Brother, are you going to put the book in a WhatsApp group or over here in a chat?
No, in WhatsApp group, brother.
Okay, thank you.
Brother Mo.
Yes, let's give a chance to folks from Dubai. Are you guys all clear? Please speak out. Anyone from Dubai? Is it clear? Are you guys good to go?
Yeah, it's all good.
Brother Mo, I have one question.
Sure.
Where can we get the recording for these classes?
You have to have access. Two ways for the recording. Either through our YouTube channel or through the Canvas.
Okay, because I looked through the Canvas, I didn't see the previous recording.
No, they are there. Let's take a look.
Okay.
These are the recording. You need to go to Analytical Project. I'm saying the program. Look into the modules. And you need to, number one, you need to identify yourself to access week number 1. And you need to contribute in the discussion board to access week number 2. And for week number 2, you need to contribute or say something about in the discussion board to access week number 3. And today I'm going to load week number 4. Okay?
Okay.
Other questions, please? Okay, folks. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. See you guys next weekend.
Walaikum assalam. Jazakallah khair.
Thank you.
Thank you.
Thank you.